And thank you everyone for being at our second session of our Routing and Switching Essentials Instructor Training class. We are going to pick up where we left off last class, which is looking at how to verify interfaces. But before we go there, I want to do a little bit of review. And what I want to do is just real quickly jump through a very, very basic router config and kind of show you the route table on a router. So I'm going to jump in here and I'm going to show you a router. And we're in privilege exec mode, so we can't make any changes. Type enable to go into, we were in user exec mode. Now we type enable to go into privilege exec mode. Then I'm going to do config T. I'm going to give this thing a host name of R1. Okay, I'm going to be line con 0 logging. Always do logging synchronous. Okay, and then I'm going to do password Cisco and then login line VTY04. Hit up arrow, password Cisco, login, enable secret, and I'm just going to do class. And I'm going to stop there. I'm going to put a banner message today and all those things on it. So at this point, I have a very basic router config. I can do a do copy run start, which would copy the running config to the start config. And the do command lets me issue a command that normally cannot be run inside of configuration mode, So if I try to do a copy run start, it's going to say there's no such thing here. There's no command that's like this. But if I do a do copy run start, it runs it outside of the context of being in global configuration or in configuration mode, which is really nice because it means I don't have to bounce all the way out and then back in. So I try to teach you those commands to save you some time. Same if I do a do show IP interface brief, and I'm going to say interface brief. You will notice that right now none of my interfaces have anything on them, and they're all administratively down, that is how if you will remember, interfaces begin their lives on a Cisco router. Also, if I do a do show IP route, you'll see there's nothing in the route table at all. So I'm going to go in here real quickly and I'm going to do a config T. I'm going to go to, I'm already in config T. I'm going to go into interface GI00. I'm going to put an IP address of 192.168.12.1, 255.255.255.0. And then now if I do a do show IP int brief, you're going to notice that the IP address is there, but the interface is still shut down. And if I run the show IP route account command again, you'll notice there's still nothing in the route table. Okay, and that's because this interface is not reachable yet. As soon as I issue the no shut command though, watch what's going to happen. Now, it should be here in a minute unless that interface, there it goes. Now it come up. All right, so the interface comes up, and now you're going to see in the route table two routes. You're going to see the connected route, which is the network 192.168.12.0/24, which is directly connected to gig 00. And you're also going to find the local, which is the /32, which is the actual IP address on that interface. Now, if I shut this down, guess what happens? It leaves the route table. Okay, so it's no longer in the route table. Bring it up, and it will go into the route table. I'm going to do the same thing here. I'm going to do GI01. I'm going to put interface. Helps when I actually put the right thing in here. Can't see here. GI0/1. And I'm going to put the IP address, and I've got too many commands to try to use it up here. IP address of 192.168.13.1, 255.255.255.0, and I'm going to do a no shut. And now there will be 4 routes in the route table. And that will be the connected route for the 12 network, the connected route for the 13 network, and then the 2 local routes. Now, please be aware these local routes do not show up in pre-iOS 15 versions. So if this was a non-15.0 iOS, it would not have the L routes. The beauty of the show IP route command, though, is it does tell you what every single item is in there and how it was put in there, which is really nice. The negative is you don't always have this on the exams, so it is an issue. All right, you say make the image larger. You talking about the inside of here? I can try. Preferences, font size. Yep, I can do it. Let's go up to 19, and let me see if I can stretch this over. Yep, there we go. How's that? Is that better, Dan? Does that help? I don't know why I didn't think about that earlier. Thank you for reminding me. But you can see now we've got the 2 connected routes and the 2 local routes. Okay, let me try that. Background, new background color. Okay. Text. How's that? We'll do the old green screen or green CRT. Yeah. It can give you cold chills too when you see a screen like this. But those are some of the basic items. Hi, Simon. These are the basic items that will show up when you configure a router with IP addresses on its interfaces. Now, of course, if I do a show run, let me go back in here. If I do a show run, you will see that the host name is here. Again, you will see that the IP addresses are on the interfaces on gig 0, 0, and 01. And in addition, you'll notice that I've got the password set here. Now, you will also notice, too, here's something I want you to be aware of, be careful of. Even though I have set the password for Telnet to Cisco, okay, and enabled login on the BTY lines, in iOS 15 and higher, the default on the BTY lines is transport input none, which means even if you have the password and login set, it will not allow you to telnet to this particular router. So I'm going to go in here real quickly, and I'm going to go gig 01. I'm going to go to this PC, and this will not be able to get much bigger, but we'll come back to it. But I'm going to go to this PC real quickly, and I'm going to give it an IP address on the 12 network. So let's go in here and open it up and do network and sharing. Change the adapter settings. All right, so I'm going to give an IP address of 192.168.12.10 and 192.168.12.1 will be my gateway. So I'm going to click OK, go here. Actually, I meant to close that. I'm going to say this is a work network. Okay. I'm going to CMD. And let's see if I can make this bigger. I don't think I can on this. Let's just do an IP config, and you will see that I've got an IP address of 12.10. I'm going to ping 192.168.12.1. Works fine. But then I'm going to try to, from PuTTY, I'm going to try to telnet to 192.168.12.1. And it's going to fail. So it just closes. And that is because I have not enabled Telnet. Now, I know Telnet is the bane of everything, and we should never use it. But just for an example here, I'm going to go into line VTY 04. I'm going to transport input Telnet. Okay. And then now, if I come back over here, and I telnet to 192.168.12.1. I'm prompted for the password, which is Cisco, and I am in via telnet. Okay, So be aware of that. That's something that can cause problems if you're not aware of it. If you were going to set up SSH and Telnet, you could do transport input SSH, Telnet, or you could do Telnet SSH. But I would never do Telnet. I would do transport input SSH, and then you can configure SSH, which you will learn how to do as we move through this particular course. And you did it actually last course. And you set your domain name, crypto key generate, and then set a local username. And you would do login local instead of login. The other item I want to kind of stress here again is don't forget service password encryption. Otherwise, when you do a run, show run, or someone looks at your config file over your shoulder, they could find that. They could easily guess your password or see your passwords. This is still easily decrypted, but it's better than someone being able to shoulder surf you and seeing what's in your particular router config. All right. So verifying interface statuses. One of the things, again, one of my absolute favorite commands is remember I can do to run a command that is not normally in configuration mode. Do show IP brief. Okay, and then you can see here the IP addresses. If I was running IPv6, I would do show IPv6 interface brief. And you'll know that there are no you can see there are no IPv6 interfaces. Remember too, if you're going to do IPv6, IPv6 unicast routing must be turned on. All right, and then you can actually go into the individual interfaces and put in IPv6 addresses, and I'm just making these up using the ACAD, actually 2001 DB8 :A:1/64, and then you can also do if you want to set the link local addresses FE80:1 link local. And then now if I run that same command, the show IP brief, you will see that I've got a link local address of FE80:1 and that assigned to gig 00. Now remember on a router you can have the same link local address on multiple interfaces. So that allows you to look at those configuration items on a router. And then you can test connectivity with pings and trace routes. And well, ping test connectivity. Trace route will show you the path. Here's an example of filtering show command. So let's, for instance, say I only wanted to start the actual filtering at line console. I could do show run, not ren, show run pipe begin line con 0. And you'll see it started showing me the configuration from line con 0 and then went down. You can have other items here. You can do include or section. So this is show running config section line V2I will only show you that one section. You can do show IP brief and then do a show IP brief pipe include up, and it will only show the up interfaces. Okay. Or you could do down, which would also be good, or administratively down. You can do exclude unassigned, and that will not show you interfaces that do not have an IP address on them, which I can understand why you would do that, but most of the time you want to see what's on every one of your interfaces. Show IP route pipe begin gateway, and that could take you into your gateway of last resort. And then this is just a little similar to have you do some of those commands, and you can actually go through and it will show you how to use those pipe commands to get certain items out of your show output. And that's really neat because it can save you time. And as you use it more and more, you'll get better at it. The command history is really neat because you can use the up arrow or the down arrow to get the history of your commands, which I use all the time, especially when I'm putting in similar things. I just have to be careful because I'll go in here and put something in. So for instance, this was in gig 00. If I go gig 01, I could come in here and I could just do the up arrow and do link local, save me typing that. I could do it again. I could go up here and say, okay, this is going to be bad, ::1, and it saved me all that time. Now do show IPv6 brief. It saved me all that time from having to retype those commands. But you have to be very careful because you also can cause yourself to have major troubles if you put the wrong configuration on the wrong interface. Okay, Simon, that's no problem. Well, as long as you can hear me, if not, you will be able to see the recording once I get it finished. Okay. By default, this is something good to know. The command history keeps the last 10 command lines in the history buffer. You can increase that if you so choose to. All right, so you can actually do that. This lab really just shows you exactly what I just did, which is the directly connected networks on a switch, on a router, excuse me. And then this is a little confusing because you think about a router just doing routing, but it's also doing switching because it is moving packets between interfaces. And this is an interesting thing. When the data gets to a router, the router is going to look at it first up through layer 1, layer 2. So it's going to look at it's going to bring it in, look at the destination MAC address, which since this PC is sending something to a remote PC, R1 would have proxied its MAC address for the Arp request. So it will find out that yes, that is indeed, the packet from PC1 is indeed intended for R1's MAC address. It would then strip that header off and then look at layer 3 to determine the destination network. It's at this point that the router does a route table lookup to determine if it knows how to get to, in this case, the 192.168.4.0 network. If it does, it will then, after de-encapsulating this packet up to layer 3, re-encapsulate the packet using the correct data link protocol for this link between R1 and R2, and then R2 will go through the same process. And this is the switching function. It brings it in on ingress port. So it comes in on this ingress port. It gets de-encapsulated. It gets re-encapsulated, switched out the other interface, and then at each hop, it does this. And like, for instance, this is a serial interface, so this is going to have to be something different than Ethernet. So it could be PPP or HDLC. So the data link information would change. So at every hop, the data link layer information changes. All right. Layer 3 doesn't necessarily change. Now we will learn about NAT and PAT and some things where you can actually do changing the layer 3 address, but in traditional routing, it does not change. Yep, very good point. George made a great point, and that is if you need to undo something, it's very nice to be able to hit the up arrow, Control A, go to the very front, type no, and then that takes that off. So now, if I do this, you'll see I took off the BBAD address from gig 01. So you can very easily jump back and forth and take something off if you need to do so. Okay? Excellent point, George. Most definitely. So this is showing you what happens here. Now here's an interesting concept. I have a packet for PC2. The very first thing PC1 does is it takes its IP address, adds it to its configured subnet mask, and determines what network PC1 is on. It then takes the destination IP address, adds it to PC1's configured mask to find out if that's on the same network as PC1. In this case, it's pretty easy to see it's not. 1.0 and 4.0 are two totally different networks. Since it's not on the same network, PC1 will then send it to its default gateway if there is one configured. If it's not, if there are no default gateways configured, it will actually drop it. Now, in that process, there's also an Arp request. That Arp request goes out and asking for the MAC address of 4.10. R1 sees that and actually does an Arp reply, which is a proxy Arp, and it'll be able to then use that to get out. Okay. Porting to the next hop, again, it's just going to rewrite layer 2 information. Okay, so every time it jumps through a hop, it rewrites layer 1, layer 2, and then it's de-encapsulated and re-encapsulated as it moves across. And then once we get to routing, this is where it goes and looks in the route table to find the correct place to send the frame out of, so what egress port it needs to go out. Now, if there's no matching destination, okay, so in other words, packet arrives, you search in the route table and you see a directly connected interface, and it looks in the Arp cache, okay, and if it is, you forward it. If not, is it a remote network? If it is, then you encapsulate and forward it out a hop. If it's not a directly connected route, it's not a remote network, and there's no default gateway set on the router, that packet is dropped. It's put in the bit bucket. It goes away. So routers, if they do not have a default gateway, which is a default route, in a router's case, it would be a default route. So you're going to learn that's a quad 0 route or a ::0 route in IPv6. They do not have a default route. They will drop it because they will not be able to forward the packet. Now, this is always a really neat concept to talk about, and this is hop count versus metric. And this is how I explain it to my students. Imagine you're going to lunch tomorrow, and you need to decide where you're going to go. What are some of the different things that you take into consideration when you go to lunch? Anybody? Time? That's a very good one. Time. How far is it from the college or from where you're at? Distance. Yep. How far away is it? Traffic, definitely, especially if you live somewhere like Atlanta. How about price? Type of food. I love Mexican food. Okay. Quality of food. Yep. Speed, definitely. Speed of service. Those are big ones there. Quality of food. All of these, folks, are metrics. Number of people in a group. Very good, Simon. All of these are metrics. They're how you decided, or your group decided, where's lunch. You used a metric. Routers use metrics to determine the best path. It could be a metric such as hop count. In other words, if a routing protocol uses hop count is the number of routers that you go through on your way to a destination. So from PC1 to PC2, there's one router, two routers, and then there's the destination. All right. If you go the T1 route, it's one router, two routers, three routers destination. So a routing protocol that uses hop count as its metric would actually see the 56K link as a better link than the routing protocol that uses the bandwidth, because it would see these two T1s as the better link, which they should be the better link. Are they always going to be the better link? No, there could be congestion on them too, but they should be seen as a better link when you look at their relative speeds to a 56K link. All right. So the metric is how you determine the best path among multiple paths to the same network. Okay. And this is within the same protocol. That's very important because we're going to learn about another concept called administrative distance. It's different. Load balancing. This is where a routing protocol can see equal cost paths. We're going to learn about OSPF that supports equal cost routing. We'll also learn about EIGRP, which actually supports unequal cost. And there's a command called variance that will let you set a range within which EIGRP will try to load balance. Now, here is the next concept. So those were our metrics, right? So all these are metrics. Metrics determine best path I'm going to decline right now, Dan, because I don't know. Determine the best path within a single routing source. So, for instance, let's imagine I'm running a routing protocol such as RIP. Metric for RIP is hop count. All right. So we're going to look at the network and determine that the best route is the one with the least number of hops. Okay. OSPF is a different routing protocol, and it uses a metric called cost, which is based upon the bandwidth of the interface. The interfaces in the path. Okay. So what I want to do is I want to go back one slide here. Okay, to this, and I want to pull this back up for us to think about. So our metrics. Let's imagine that these routers are all running both RIP and they're running OSPF. So we're going to determine that RIP, the best, okay, which in this case would be through R1 to R3, right? OSPF using cost is going to say the best path is R1 to R2 to R3. Okay? But the metric was used within each protocol to determine the best path. So OSPF determined that this was best, PIF determined this. But now, which one of these two will go into the route table? To do that, to determine that, we use administrative distance. And it is it's not really reliability, but it's the trustworthiness of a routing source. Okay? Now, by the way, a connected route has an AD of 0. A static route has an AD of 1. Those are extremely well-trusted routes because they're trustworthy. If it's connected, you're getting there through the connected interface. All right. RIP has an AD of 120. OSPF has an AD of 110. Make sure I didn't blow that. I'm pretty sure that's right. Yep. OSPF is 110. All right. But now take a peek at this. This is very interesting. EIGRP is Cisco proprietary protocol, even though I know it is actually could be open now. But EIGRP, okay, internal EIGRP has an AD of 90. EIGRP is a distance vector routing protocol we'll learn about in the next chapter. So why does it have a better AD than OSPF? Because administrative distance is the Cisco method or the Cisco device used to determine the trustworthiness of a routing source. So in their determination, EIGRP is more trustworthy than OSPF. All right. So some of these to remember again: connected, static, EIGRP of 90, OSPF 110, RIP 120. And then the max is 255, which is unreachable, so are not trustworthy at all. So that is what AD is, and that is the difference between a metric, which is within a single source, and administrative distance, which is determining the trustworthiness of a routing source itself. Does that make sense? Any questions on that? Okay, you see the AD in the route table when you do a show IP route. It's actually shown, except for connected. You will see it's timed out on me. Okay, so connected you don't see it because it's 0. But if there's a static route, it would actually have a 1, unless someone put a static route in with an AD higher than 1, which you can do. So again, our routing table, this is what I've been showing you here, these directly connected routes versus remote routes. So if you look at this router right here, it should have 3 directly connected routes and 2 remote networks. Routing table sources, again, these local interfaces is iOS 15 or higher. You've got directly connected, you've got static routes. That's when you use the IP route command that we'll use later. And then dynamic routing protocols. And so some of these will show in there. D is for EIGRP, and you will learn that's because EIGRP uses the dual or diffusing update algorithm. So here we have an example of a remote entry. D means it's EIGRP. This is the destination network. The first item in brackets is your administrative distance. The second item is your metric to that network. How you can get to it, in other words, what IP address do you go to get there, next hop IP, and then the outgoing interface, and then this is how long you've known about the route since it was discovered. Being able to read a route table entry is extremely important as you move forward in CCNA. Okay. So again, anytime you issue the no shutdown command, you will see a directly connected route. I'm not going to spend much more time with that because I've shown you this several times. Same thing with IPv6. It will go into the route table as soon as you do a no shut and the interface is up. Now, static routes. Why are they good? Well, sometimes you have small networks. Let's imagine this, and there's absolutely no way for R1 to get to any other network except through R2. You could put on R1 a static default route that points everything that it doesn't have directly connected to R2. And so in other words, it would know how to get to the 10, the 11, and this 209 subnet. Okay, so these networks in that subnet. And it will have a default route that points to R2 for everything else. And that would tell it how to get to 10.1.1.1, 10.1.1.0, and 10.1.2.0, plus to get to the internet. Then on R2, you could do a static route to the 10 and the 11 network, and you're done. And the beauty of that would be you have no dynamic route updates going across the link. You have better security because you don't have to worry about any of your dynamic routes being intercepted by anybody if you are not running authentication. It's simple. You know where things are supposed to go, and you know exactly what direction they're going to go. Static routes are not a bad thing. Here's an example of a default route, IP route, it is an IPv4 default route. IP route quad 0, quad 0. So this is a default route to any network that's not in the routing table already. You can either do the exit interface or the next hop IP address, or you can do a fully qualified, which is both. And you can also do a static, just a typical static route. This is the default route here on R1. Okay, outgoing interface 0000. The nice thing about using the outgoing interface is if you change the IP addresses on that interface, you don't have to change your static route. Can you see how it goes into the route tables of directly connected route? And they got you doing a little default route there on that. And here's your static default route on IPv6. This is the ::/0, which is the same thing as quad 0, quad 0, and outgoing interface. And they have the exact same thing. You'll see it in the route table. Now these are static routes that are, in order to get from R2 to this network, it says to get to DB8 ACAD1 subnet, go over to ACAD3:, which is here. All right. Or exit this interface, and that's to get to 2. So either one of those would work. So it's just like the static route for, oops, excuse me. I do have to show it this way. Hold on a second. There's a default route, and then here we're going to do it on R2. You're sending the IP route to the 3 network via S000 and next hop. This is called a fully qualified route because you're doing both. Not necessary, but it's possible. Especially, it's good to do if you're going across Ethernet, because that Ethernet allows you to. It will help you with the There really are no recursive lookups anymore because of Ceph, but it will help with the ARP table lookup. Static IPv6 routes. Now, dynamic routing is, let's imagine that we are starting with this, but we're going to be adding a large number of more branch sites out here. So R2 is our central office. We've got one branch site, but we're going to add 10 or 11 of them in the next 2 or 3 months. Configuring static routes out to every one of those branch sites would be a pain. So we can put in a dynamic routing protocol and say, hey, advertise what you're directly connected to. And so R1 can say, I know how to get all these networks. Now R2 would ignore the 209 advertisement because it would say, hey, I'm already connected to 209. Don't tell me how to get there. I know how to get there. But it would then see the two networks of 192.168.10 and 192.168.11 and say, I don't know about those two. And then it would put it into its route table so that it would be reachable, and vice versa. R1 would learn about the routes here, and you can set or redistribute a default route from R2 into R1 depending on the routing protocol, how it's set up. So here's some of them: BGP, EIGRP, OSPF, ISIS, and RIP. We're going to talk about EIGRP, OSPF, RIP, and BGP in the CCNA. Here's an example of a router learning. This is a EIGRP routes, and this DEX, this is a route that has been redistributed. That's an external. You'll notice the typical administrative distance for EIGRP for internal EIGRP is 90, but external EIGRP has an administrative distance of 170. It's less trusted because it's come from an outside source. It's not really something that's that big to know about in CCNA, but it's a big concept in CCNP as you move forward to route switch. IPv6 routing protocols, you've got EIGRP, OSPF, and RIP, or RIP-NG. Those are the dynamic routing protocols available for V6. And you got IPv6 unicast routing has to be turned on in order for any of these to actually route, to be able to route between IPv6. And then, let's see here, that's pretty much it on Chapter 1. And you're going to do some basic labs on configuration. By the way, when you click course index, you can always see under packet tracers, you can see what packet tracers, so you're actually going to do some static and default routes in Chapter 1, excuse me. You're going to look at the static and default routes and do some basic networking. Review some items in terms of IP4, IPv6 connections. And then on your labs, the labs are pretty easy. You got one lab inside of NetLabs that lets you review all of the configuration of a router. The next chapter we're going to get into is static routing, so it just takes what we just learned about static routes and goes a little bit further with them. Then we'll move into dynamic routing and then into our switching VLANs and on 2 other items that we have here with DHCP and NAT, which is a hugely important concept in anything that we do in today's networks. Are there any questions on the finish for Chapter 1's lecture? Hold on a minute. Let me turn up my volume. I think somebody say something. Hello? Okay. Nobody say anything? All right. Well, I am going to end the recording.